Hello and welcome to today's CamLogic Tech Tuesday. Today we're going to talk about what I'm calling simple reuse libraries in NXCam. So just take a moment to introduce myself. My name is Saul Cunningham. I'm an NXCam application engineer here with CamLogic. I've got 10 years industry experience and 5 years programming machines, and I'm training fellow employees on how to use various different types of CAM software and like I say, running machines, programming, all sorts. So what I want to talk about today is a way, NXCam can be a little cumbersome. It can be a little trying sometimes. So especially for new users. So what I want to talk about is a real simple way to jump in and start to customize your environment so that you can get the most out of it, get the most productivity, and to reuse a lot of that knowledge that you've developed on say older projects, or to keep your tool library up to date in a real simple fashion that's not going to require a lot of top level stuff or a special IT guy to help you give permissions to certain things. So what we're going to do is, like I said, get started with CAM customization. We're going to create a template file, and in that file we can contain tools and different operation types, even different geometry groups if you wanted to bring them in that way. So we're going to pull from this template file to program new parts, and then we're also going to bring in information from other programs maybe that you've already done that you want to help to build up your template file to help you reuse that stuff and to maintain accuracy moving forward. So the way it's really going to work is it's going to be a setup file, just like you'd normally do. Open a part file, create a parent file around that with a manufacturing type, and then we'll bring in all the different operations and tools that we want to, and then we'll strip out that original part file and just have that be a standalone part that we can bring and copy paste in between. And then that's what I just talked about. And what's really important is that when you start a new part, we'll open this file up right next to it, and then we can bring in just the operations that are applicable to that new part and the tools for maybe a specific machine or just a set of operations. So let's just jump right into it. I want to show you how we're going to go about that. So here's a real simple part. This is like a mold insert. So just modeled that right here in NX. And just like we usually would, I'm going to go ahead and create a setup file for that. And that's going to be a manufacturing subtype. Not going to worry about file name or any of that right now. I just want to create a general setup. You'll have to do one for inches and millimeters. This one will just be for inches here. If you wanted to do this for millimeter tools, or if maybe you run a different machine, or certain projects in millimeters. So here's our blank part, and just like usual, I'm not going to go ahead and bother to change the machine coordinate system. That's not really going to affect what we're doing here. But because I am going to create a few operations, we want to define the blank as we usually would, or excuse me, the part. That was the part. So we're also going to define the blank as a bounding block. And just give a little bit of stock to the top of that. Okay. And the other thing we'll have to do is set up some tools. So I have a few predefined tools down into the template of the mill planer file. So those pop in when I use that. We'll discuss that perhaps in a future video, how to get those to populate automatically. But just to show you what I have in there, a couple half-inch, quarter-inch, some ball mills, some real standard type of tools. But let's say you wanted to make a new carrier. So we can call that vertical machine center 1. Do that again real quick. So now we've got my default carrier, which let's go ahead and just borrow a few of these tools. We can create some others as well. For now, I'm going to delete this one, so we're just looking at the one that we're focused on. Paste inside? Nope. Paste inside. So now we've got a couple of different pockets with those tools in there. Just to stay focused, I'm going to delete that. Let's create another tool. Let's say we've got a 1-inch hogging tool. We'll go ahead and put that into VMC1, and that's a 1-inch end mill. Keep that simple. I didn't put that in a pocket, so let's go ahead and insert a pocket. Obviously, you got to keep these numbers intact here, and then they also have to be unique. So if you did want to say set up 2 separate machines in here, this is one thing you'll have to remember. So say you wanted to set up 2 machines. I couldn't call this mill 1/2-inch square, and it'd have to be a unique name. So that can be a little challenging. So you might want to keep the tools general, not specific to a machine, or have another template file for each machine. And then you can still copy and paste back and forth between those 2 templates if you just open them up next to each other. So now that we have a few tools created, I'm going to go ahead and create a couple of operations real quick, just to show you how those are going to transfer back and forth. But before I do that, let me rename this. I'm going to use underscore there. So template operations. So I can copy into, when I start a new part, I can copy this one folder group. But I can also make program groups inside of that. So say this is roughing. So trying to do this in real time here for you. So this is just a way to organize those into different folders. So then you can copy this whole folder into your new program, and it'll come with subtypes of operations underneath that. Instead of having them all in one long list, you can start to organize those, because you want to make sure you keep your naming convention specific, so that you know which one you're grabbing when you come to that point in the future. So again, let's create a quick cavity mill. I'm going to put that inside of roughing operations, and I'll use that 1-inch mill. stick to the workpiece, and obviously that'll be a rough. So I'm going to call this cavity mill rough, and that's a 1-inch tool, something like that. So real quick, let's just see what that generates. So it's going to climb. It's got quite a few levels. I think we could take off a little more material. I'd like to be a little more aggressive with that 1-inch tool. So I'm going to modify that real quick. Let's see if we can go 30% of the tool, but we can do 3/4 steps. Let's see what that gets us real quick. So it's still taking those levels at the top of each surface there. But then when it gets down to it, I think it runs pretty quickly. And again, you want to keep these operations general. We don't want to go in and specify geometry for each cut level. So we want it to work universally for the next part. So for that roughing operation, I like that right now. Let's go ahead and make another group. One of the first things I like to do on a die like this is take that large tool that I've roughed it down with and go straight to 0 on that mating surface. So let's keep that same tool. I'm going to get a floor and wall operation, except this will be a finish operation. So we'll put it in that finish ops template, and this will be let's say mold part of surface. And again, that was a 1-inch mill. So we got to capture as much of that in that file name as we can. And we don't want to keep the selections of the geometry down. Obviously, I do have to select the floor. And I'm going to go zigzag, and I am also going to add a finish pass so that it does a final cleanup of any islands. So let's do a generate there and have a quick look. So there we go, back and forth, and it follows with a finishing pass around that island. So when I copy that into the next part file where I want to reuse it, all I have to do, again, if it's a mold like this, is to go ahead and select that floor. So I think that's great. One final, let's do a semi finish operation. Say with a 1/4-inch ball mill. That'll be a semi, and then I'm going to use rest milling or cavity milling with IPW. So again, this is going to be a semi finish, and that is okay. So there again, we're going to be specific about how that naming convention goes. So thinking about this real quick, step over, I'm going to go by scallop, and step down, I'm going to keep it to a 1/16 of an inch. Let's just see what that nets. Okay, I don't think that's in order. rest milling has to be after. So I just had to reorganize those a little bit. Let's do a regenerate that. I don't want it to cut the floor. I've already cleaned that, so it shouldn't need to cut any of that parting surface. So again, that looks great. Obviously, you're going to have to fine tune any of this for your operations, but this will give us a good start to roughing. So okay, so now those are in the right order. So now that I have some of these operations and some of these tools brought in, again, just showing you the approach here. I'm going to save this as, I'll do a different version here, but you get the idea. It's going to be my custom template, something to that effect, company name, whatever it might be. I've used a set of zeros there to keep that file at the top of my list, so it's always easy to grab. And what that part does is it still references that the setup part still references the actual part of the actual geometry part. So now that I've saved that out, I'm actually going to come in here and delete the part right away from it. It won't delete the file, it's just taking away the connection here to this assembly. So do a quick save of that. And then to show you how we can reuse that information on a new part, rather on something that I've already modeled. Here's a different, I thought these looked like the backs of video game controllers or something. But again, it could be another mold insert, something where we could use a similar set of operations. So this doesn't have a setup yet. It's just a part file. You can see I modeled it right here in NX. So this is our new file that we're going to take advantage of that custom template and import those tools and import those types of operations, and do that real simply and quickly without any kind of deep IT knowledge or deep knowledge of NX. Say you're just getting started. Again, I'm going to create that manufacturing parent file around that in inches. I'll just accept those defaults. That loads up here. I'm going to start just like usual. Here we'd want to define the MCS, how you want to see fit, obviously, because this is where you're going to run apart from. But we'll do the same basics. We're going to go into that workpiece geometry. We're going to select that part. We're going to go and define the blank as define that as a bounding block. Add a little bit of material to the top, just like we did before, to have something to machine from. And here you can see the program is empty. The tools, well, we can say they're empty. It's going to have those couple that I did define in the mill planer template. We can go into that in a future Tech Tuesday, but for now, let's say that's none of that's here. Since we're looking at tools, let's go ahead and bring those in first. I'm going to copy this whole carrier for the vertical machining center or just my general tool list, whichever it might be, whichever works best for you. I'm just going to copy and paste inside generic machine. And now you can see we've got a handful of those tools just come right in. They come in with the pocket number, with the tool number, with any offsets, feeds, and speeds you might have. anything that you might have programmed in, the material that tool is, any tool holders, anything that you can attach to a tool will be copied in with that. So that's really useful as a simple way to maintain your tool library. So the next thing we'll do is bring in, like I said, we'll bring in that whole set of template operations. They don't have to be collapsed. I'm just showing you that they are all under one program folder. So we'll copy again, switch back to that new part, and then right here in the program view, I'm gonna put them here at the main program level, and then assuming you had a great deal of operations built up into your setup like this, you'd want to just drag down So I'm going to go ahead and drag down all three of these because I'm going to. Those all fall in. And then oftentimes, once I think I'm done with that, I can pull this template operations up into unused. And it won't calculate it into IPW. It won't get in your way. But if you need to, you can always pop back in and drag them out of that unused or kind of null folder. So cavity rest. Nope, we're going to switch this. Switch that order real quick. And just to show you what's going to happen, since we stuck everything to workpiece and we've maintained those, we set those up again, I'm going to show you what would happen just if I generated this without selecting anything. So what's going to happen, or what is happening, is that there's no floor selected for that floor and wall operation. There was no way for it to associatively select that part there. But I can accept the pass that it did get to. There again, no floor and wall, or rather floor and wall geometry must be specified. So easy to do. Pop it open, just like we did before. Select that floor. Now I know that I can generate this floor and wall, and then subsequently that rest mill operation will work because it has the IPW from the previous operations all set up. So let's just do a quick visualization on that whole program, and you can kind of see. Granted, this is not highly tailored to, but even if it was just a set of roughing operations that you wanted to bring in, and then you got more specific with your finishing operations, you could see how this might save some time, especially once you start to develop that tool library, your operations library, your different roughing strategies, and you'll know where to apply those to make sure we get this work done quickly. And you saw me reorder them, but already I'm seeing something relative to this toolpath. I'd like to have it just spend the time on one of these mold inserts rather than jumping back and forth. What's happening there is it's going by level instead of by depth. So I'm going to go ahead and cancel right out of that. But instead of changing it here, because I know I want that to apply to my whole template, I'm going to go ahead and come into that rest mill operation, and I'm going to cut each of those first. Could be different depending on your case, but I know that I want that to do it this way. So I'm going to change it back here in my templates to make sure that I have that going forward for separate parts. Obviously, if it was something specific to this, you could change these operations here. But this is a change that I want to maintain in my template. So I'll even go ahead and save that. And then I'm just going to recopy this rest mill back into here. So that ungenerated one is the new one. I'm just going to delete this and regenerate this one. And now when I do a toolpath verify, what we're going to see is it'll focus on each part. So we'll save a little bit of XY travel time. Not enough to run out and buy your new boat, but hey, it's a little bit of time, and over a lot of parts, it might be enough to make a difference. So I just want to point out how to go back and change that in the template. Even though we're working on the finished part, I found something that I wanted to change in the template. I want to save that for the future. So that's a quick way to go ahead and make sure we've done that. And that's really most of it. You can see how you could build on this and really start to create a library. You could even save this my custom template right to your desktop, wherever it might be easiest to get to. But one other thing I wanted to show you real quick is how to bring operations in, maybe from other parts that you've already programmed. So I'm going to copy it from a separate template file. Like we said, you might have a different template for each machine. You might have another thing going. So here's how we're going to copy something back into this one that we've created today. And it's just a simple copy and paste. This is an adaptive mill. I've already taken out the part file itself though, so I can't really show you that run, but it's an adaptive milling. It's a roughing strategy. It's a great roughing strategy. Allows you to get more use out of that flute length. If you haven't heard that before, look at some of our other videos we have on that. But again, I'm just going to copy and come back, and that was a roughing strategy. So I'm going to paste it inside of there, and now we have another method to work with that. So you can copy in old operations and then maintain those tools as it works as well. So let's just touch on why that was useful. It's just another part file, nice and easy to maintain those, to open them, edit them, store them, copy them, move them around. You don't have to have any admin privileges or mess with any UG environment variables or anything like that. So, and we're also just copying and pasting. Like anybody can be taught that concept even if they're not familiar with it yet. And again, it's a simple approach, but for the right users, if it's a small shop, if you're a one-man operation, or if there's just a few of you, or even if you are in a larger organization, maybe you don't have access, maybe you don't have admin access, and you just want to start to increase your workflow. This is going to be a great way and a simple way to let you do that here in NXCam. So just wrapping up, I just want to make myself available. If any of you have any questions, feel free to drop me a note. And then also the help desk. You can reach out to us anytime. There's the main 800 line and the support email. Bring you right to our help desk. So thanks so much, guys. Have a great day.